Something I didn't add in here is Newton's law of cooling, but we'll probably just look at that with an example, and we might wait and do that when we actually get back from break instead of trying to get that in the next, class and a half, basically. I just don't think we'll have time to get through it, because I also want you to have time to do problems and stuff and not have to worry about it over break. So, use separation of variables to solve the initial value problem, indicate the domain over which the solution is valid. We probably will look at that, but not in super depth. So 2 dy dx is equal to negative x over y, and y equals 3 when x equals 4. So I need to get all the y's on one side, all the x's on the other. So this one actually is going to work out quite nicely since this was written as a fraction over here already. The negative can really stay on either piece, but I would tend to just leave it on the x, like the term that's on top. So we'll multiply by y and multiply by dx. So basically we're cross multiplying to give us y dy is equal to negative x dx. So then I'm going to anti-differentiate both sides, so put an indefinite integral on both sides, and I'm going to look at each side individually. So you can cover up one side and just look at the other. So what would the antiderivative of y dy be? One half y squared. And on the y side, we will not do the plus d, but on the x side, we will. So then over here, the antiderivative of negative x dx would be what? Negative 1/2 x squared plus c. Now, c is just some constant, okay? So at this point, does it matter if I multiply that constant by 25? Is that going to change anything? Because I don't know what that constant is, right? That's not going to change anything. So I can almost proceed with this problem as if it's not there for the moment, okay? Obviously, I will have to eventually come back to it. But how can I simplify this as it is right now? How would I undo the 1/2 on one of them?
You would have to. Wouldn't that just be putting it on the other side?
Can I take your bulletin board down?
Sure.
You want it all saved?
Thank you.
Well,
If she's bored.
Would you have to divide it to the other side? But wouldn't that mess something up?
Multiply.
Multiply, yeah.
Yes. So if I do that, so I would have to multiply by 2, right, to cancel this on this side, and I'd multiply by 2 over here, and so when I do that, so I'm just going to do this. When I multiply by 2 on both sides, that's going to cancel all that out, right? Obviously the 1, too. So I'm left with y squared is equal to negative x squared plus c. That's why I asked you the question of, does multiplying c by something change anything? Does making that 2c, does making that 2c change anything? And the answer is no, because I don't have c yet.
Yeah.
If I already had it, because right now it's just a random constant. I don't know what it is. So I need to solve for c. So I'm going to, and I'm not done with the problem yet, but I'm going to go over here and off to the side I'm going to solve for c. And so I'm going to plug these numbers in. So I've got 3 squared is equal to negative, and then 4 squared, make sure you know the negative isn't getting squared, plus c. So this is 9 is equal to negative 16 plus c. And so 25 is equal to c. I promise when I asked you if you could multiply c by 25, I did not know that's what that was going to come out to be.
I was like, oh, is that what you did?
No, I just randomly made up a number. I was gonna do like 3, and I was like, no, I want to do something like dramatic, like.
Dramatic.
Just, okay. Didn't know it was that dramatic, but it's fine. So now I need to get y by itself over here. So take the square root of both sides. So that's going to give me y equals the square root of negative x squared plus c. But I have c now, so this is going to get plugged back in. And so y equals the square root of negative x squared plus 25. And so this would be what I'm looking for. Then it asks about the domain. Okay, so where, like basically, is this all real numbers or is there somewhere that's a problem? Like what interval is this work on? This domain's been a hot minute ago. What values can I not have under a radical? Negative. So I would take what's inside here, negative x squared plus 25, and set that as greater than or equal to 0, because 0 is okay, but negatives are not. So then subtract 25, so I got negative x squared is greater than or equal to negative 25. What happens when I divide by a negative? Flips it, so x squared is less than or equal to 25. So what does that mean? Or, yep. So we're going to have x is less than or equal to 5. And then on the other one, because it's the negative one, we also have to flip the inequality. So x is greater than or equal to negative 5. So that means that my domain would be from negative 5 to 5. For some reason, they don't have the including, but it should be including because we can have 0 under there. We just can't have negative, so. I don't know why they did that, except for most of them are like something to infinity, so I'm guessing they just did it out of habit. Okay, let's get another one. For dy dx is equal to 2xy, y is equal to 3 when x is equal to 0. So I need to get all the y's on one side, all the x's on the other. So what do I need to do in order to do that? And I mean, it might look weird. How do I, okay, well, let's start with dx. How do I get dx from the left to the right where my other x's are? Multiply by dx. And then how would I get rid of this y over here? Divide. So this is going to be 1 over y is equal to 2x dx. Oh, and I guess I need the dy over here still. So then I integrate both sides with respect to their variable. So that left side is kind of weird. That's like one of our special ones. So what does that give us? ln of y. And how about the other side? X squared plus c. Let's see, what do we do now? Ultimately, I'm going to need to get y by itself.
So do we just go ahead and do that?
How would I do that?
Can we just divide by ln? Or is that not how that works?
Can't divide by it. How do I undo a log?
The is a thing. I don't know.
So what I can do, show you a little trick, is I can actually make that so that E, with all of that being raised to it, so that it cancels. So then I would end up with y is equal to e to the x squared plus e to the c. But I need to find out what c is equal to, right? So I'm going to go back, now that I've got that set up, I'm going to go back to this equation. The ln of y is equal to x squared plus c, and I'm going to plug numbers in. Okay, it doesn't really matter what order you did it in. Like on the last one, we plugged numbers in, then we went to here. But you can, whatever order floats your boat. It doesn't matter. So the ln of 3 is equal to 0 plus c. And you're going to notice this one isn't necessarily quite as pretty. So we'll need our calculator to find the ln of c. Actually, just leave it. Okay, now, let me tell you why. Because when I plug this back in over here, and that's also why it was good that I did it this way first.
It'll cancel?
Yes, it'll cancel. Because it'll be e to the ln of 3, and the e and the ln are going to cancel and just leave me with 3.
Okay.
Now, if you went ahead and found this
C will
number,
really just be 3 at the end.
that term is going to just be 3.
Oh.
Because if I did this, I'm going to get something along the lines of like, I think it's like 1 point something. And so if you did e to that, it's going to end up giving you something really close to 3 because e is 2.71. So when you raise it, it's going to end up giving you that. So if it was a different scenario, we might multiply through. You could multiply it through and that would be fine. But we're going to add it in, or like just replace c with the ln of 3. Because ln of 3 is a number, so I can just plug it in. So this is going to now give me y is equal to e to the x squared plus e to the ln of 3. Now, you wouldn't necessarily have to write all this out if you were doing it, but just for sake of seeing it and for Ethan when he goes back for it. So then now, e and ln cancel, so I have y is equal to e to the x squared plus 3. Hold on a second.
Self-expect.
Yeah, you do.
Eden's got the Olaf forehead down.
Leave me alone.
What?
Okay, hold on. We need to backtrack for a second. I forgot about a rule.
Oh.
What we've done is fine. Just the last, we just need to go change a sign in here. So when I have this, okay, I actually am supposed to put the plus c up here in the exponent. Because just the plus c at the end isn't really there. And also, I can, it's supposed to be e to whatever times like e to the c, so then you add them together. just show you. So it should end up looking like this. So we started with okay, obviously this isn't exactly what we started with, but close enough. But dy dt is equal to k times y. So we had to move this over here. So it was 1 over y dy, right, on that side. And then obviously over here, k dt, which ours would have been.
So you're
X.
saying
So what
it
we
should have been like e to the x squared plus c?
yes.
Oh.
In the exponent, it should have been plus c.
Right.
So then we could have split it if we wanted to, like this, e to the c, e to the kt, which is why we're going to get the same answer either way.
Okay.
Oh.
But that's why it should have been like that, because then our final answer will actually end up being a little different. So just at this point here, gonna make this plus c here, and I'm gonna get rid of that e there. And so then still plus c, and then here this would be e times, or e to the x squared times e to the ln of 3, because I can split it, right? When I add the exponents, I can split it and they're multiplied because they have the same base, which now gives me that when the stuff cancels. And so the final is y is equal to 3 e to the x squared, which obviously is what I had it or I just need to rewrite it. Yeah, I forgot about that rule because that's one of those weird ones that when you have it like that, the plus c actually goes in the exponent, not the...
Right.
Well, I say that. We raised both sides to the e, right? So when I did that, what happened is this should have all become one piece
Okay.
when I did it, and I split them instead of doing it all as one thing. So that's really, I guess, the technical reason behind why. But I always forget about that when you have it. That whole piece has to be raised to that. So if there was other terms there, like potentially that whole thing would have like been raised, but then because it was added, we can do it as multiplication. Let me see if I can find another one that's kind of like that.
So did you find a domain? Or something?
Well, what's the domain of an exponential function? Yes, we do need to find it, but what is the domain of an exponential function? What does an exponential graph look like?
They're like the lines people love.
So an exponential graph looks something like this. So what would the domain be?
Pause.
Put everything above. Or is it
So
going
remember,
like that?
domain is x,
Infinity.
Yeah. Oh, yeah.
infinity. So negative infinity to infinity are all real numbers, however you want to write it. Something like that would be your domain. Now, obviously, this isn't a great necessarily depiction of this graph in particular, but this was just what a parent function looks like. Okay, let's try another one. We can put all the pieces together. Let's see if I can not make a mistake this time. 6. dy dx is equal to cosine squared of y, and y equals 0 when x equals 0. So what do I have going on over here?
There's no X.
There's no x, but I still am going to proceed like I normally would have. So I'm going to move the y stuff over and I'm going to multiply by the dx. So on the left, I'm going to have 1 over the cosine squared of y, dy, is equal to dx. And obviously, like, there's an imaginary 1 in front of it. Is there anything you see that I can do before I integrate?
Well,
You're on the right track.
Yeah. Could you make 1 over cosine? Wait, is that would that be secant? Secant?
Yeah, and it will be
Make it
squared
secant
because,
squared?
yep, because that was cosine squared. So this is going to be secant squared of y dy is equal to dx. Now I can integrate both sides, and that's nice because I know what the integral of secant squared of y is, right?
Tangent.
So I'm going to have tangent of y is equal to what?
Plus C. Or C. Plus or minus.
What's the
C.
antiderivative of 1?
Oh, X.
X.
So x plus
there's
c.
X.
Oh, that's right. You did say there was an imaginary one.
So then, now again, we could go ahead and solve out for y if we want, or we can go ahead and solve for c, like either way. Which one do y'all want to do? Or what thing do you want to do first? It really doesn't make a difference.
Solve for C.
Solve for c. Alright, so we're going to have the tangent of 0 is equal to 0 plus c. What's the tangent of 0? 0. So c is equal to 0. So that just means that c is going to disappear at this point. So I've got tangent of y is equal to x because c was 0. So now, how do I solve for y?
Inverse tangent.
Take the inverse tangent. So y equals inverse tangent of x. Now, this is probably not something that you just happen to know the domain for,
No.
I would
I
assume.
didn't know for the other ones either, so. I
And the
wouldn't know.
exponential was.
So, let's, because I highly doubt you know what this graph actually looks like, let's try to do it. Make sure you're, well, I don't think it really matters, but I would say make sure you're in radian mode if you're not already. I always have to check because people use my calculator in other classes and I never know which way it is, so I'm always like paranoid about it.
That makes sense.
Yeah.
I also, I'm in polar mode, so I'm gonna go get out of that.
Polar mode. Okay,
Yeah.
Is
we're
that
doing polar
for
functions.
pre-calc?
Yeah.
Oh yeah. How did that? Do you know how that quiz went today? 'Cause we're-
Oh,
They haven't all finished it yet, so.
Oh, was it on polar functions?
That's what I heard.
I mean, I didn't try to make it that hard. Like, there's a few things I could have put on.
It's 139.
Is it really?
Yeah. What?
Okay, well, we'll just pick up this problem tomorrow, I guess.
Dang, I didn't think.
That flew by.
Anyways, if I remember correctly, we'll look at y tomorrow, but, well, I know that the domain is going to be all real numbers, okay? It's because the tangent function goes from looking like this to like this,
Oh, so
I think.
Okay.
So it just goes on all real numbers, but we'll verify that tomorrow because I haven't graphed that in a long time, but I think that's what it looks like.
That's-
Don't quote me on that till after tomorrow.
Okay.